Hello friends, welcome to lecture number 13. In this lecture, we will read about potential energy of various system of charges. To start with, we will go for potential energy due to a dipole in a uniform electric field. Okay, so we have already found out the torque experienced by the dipole in a uniform electric field, that we have already done. Okay, so what we do here, that for a uniform electric field, how it is represented? Parallel lines, we already know it. Then we have a dipole minus q and plus q, where the forces are falling as minus qe, and here it is plus qe. Okay, so these are the two forces, and the distance between the two dipole is 2l. Okay, so we know that torque will be falling on the dipole. So torque on the dipole is torque on the dipole is how much? We have already found out, tau p e sine theta. Okay, now what does this torque do? This torque tries to rotate the dipole in the field direction. Okay, so a very small amount of work is done in rotating the dipole through a small angle d theta against the torque. So the small amount of work done will be how much? dw will be equal to tau d theta. And what is tau? Tau is pe sine theta. So pe sine theta d theta. Okay, so the total amount of work done in rotating the dipole from orientation theta 1 to theta 2, how much it will be? It will be your integration dw 0 to w will be equal to pe sine theta d theta integration. So p and e are constant, they will come out of the integration, and the limits will be from theta 1 to theta 2. Okay, so sine theta integration is minus cos theta, so minus pe cos theta, and the limits will be from theta 1 to theta 2. Okay, so if we expand it, minus pe cos theta 2 minus cos theta 1. Okay, so if I reverse it, the minus sign will come out, so minus minus becomes plus pe cos theta 1 minus cos theta 2. So this is the work done, okay, for rotating it from angle theta 1 to theta 2. Okay, so let us now concise it. If we consider theta 1 is equal to 90 degree, so what does that mean? That means initially, the dipole is kept perpendicular to the electric field. Okay, and then theta 2, let us assume as theta, okay, which is shown in the figure. This is the theta which is shown in the figure. Okay, so we have taken theta 1 to be 90 degree and theta 2 to be theta. Then what will be the work done? It will be pe minus, because cos 90 is how much? 0, that is gone, so minus cos theta 2. Theta 2 means theta, so minus cos theta. Okay, so that comes out to be minus pe cos theta. So if it is cos theta, then it must be your dot product. Okay, so the work done will be equal to minus p dot e, and this is nothing but your potential energy. This is nothing but your potential energy. Okay, so potential energy due to a dipole will be dot product of your dipole moment and electric field. Okay, so now let us write down some note about this. The first note is, you'll see here, the first point I write, that is your stable equilibrium. Stable equilibrium. So what happens in stable equilibrium? Theta is 0 degree. So if theta is equal to 0 degree, you will be how much? Minus pe, which is your minimum value. Okay, so basically theta equal to 0 means what? Your p vector is parallel to e vector. Okay, now what is the second case? It is your unstable equilibrium. It will be your unstable equilibrium. When can we achieve it? We can achieve it when theta is equals to 180 degree. So U will be how much? Cos 180 degree means minus 1. So it will be minus plus. So PE, which is your maximum value. Okay. Here your P vector is anti-parallel. It is anti-parallel to E vector. Okay. Third case, if theta is equal to 90 degree, then what it will be? Your potential energy will be 0. Okay. So this is all about your potential energy due to a dipole in a uniform electric field. The second part what we are going to study is your potential energy of a system of 3-point charges. Okay. So now we will study about potential energy of a system of 3-point charges. This comes for a 3-mark question. Very, very important. Try to follow. Okay. So for that, for the 3-point charges, now how am I going to place these 3-point charges? Let me form a triangle in this form, this manner, and I will choose different points, positions. So suppose this position is P3, this is your P2, and this is your P1. So these are the positions, 3 different positions of the triangle. Now what I have to do, I have to bring one of the charges, one of the one charges one by one, and place at the position. I will bring Q1, place it at P1. I will bring Q2, place it at P2. I will bring Q3 and place it at P3. Okay, everywhere I will place it here. Okay, now what is the distance here? Distance is, this one is R13, this distance is R23, this distance is R12. Okay, now what will be the amount of work done to bring the charge Q1 at position P1? So work done to bring Q1 at P1. How much? Since no other charges are there, so I have to do no work. So work done will be 0. So what then next comes? What is the work done to bring Q2 at P2? And mark it. While doing so, Q1 is already present at position P1. So W2 will be how much? Potential at that point into the charge. Okay, potential is V1 into what, which charge is Q2. So what will be your V1? K Q1 Q2 divided by R12. So this is the work done to bring the Q2 charge at P2. Then third one, work done to bring the charge Q3 at P3. Remember, here already Q1 and Q2 are at their positions. So W3 will be how much? It will be first potential at P3 due to Q1 and Q2 multiplied by the charge. Which charge? Q3 charge. Okay, so what will be the potential at P3 due to Q1 and Q2? It will be K, common I will take it, Q1 divided by R13 plus Q2 divided by R23 into the charge Q3. So if I expand it, I will get K Q1 Q3 divided by R13, let me take K as common, plus Q2 Q3 divided by R23. So this is what will be your work done to bring the charge Q3 at position P3. So what will be the total work done then? I have to add this one and this one. These 3 will be added. So the total potential energy of this system, it will be how much? U will be equal to W1 plus W2 plus W3. So if you try to expand it, U will come out to be 0 plus K Q1 Q2 divided by R12 plus K I will take common Q1 Q3 by R13 plus Q2 Q3 divided by R23. Okay, so this is the expression. So finally, what if I write down in a proper manner, U will be equal to how much? K within bracket q1 q2 divided by r12 plus q1 q3 divided by r13 plus q2 q3 divided by r23. So this is the potential energy. Okay, is it clear? Now instead of 3 point charges, there might be question for 1 mark questions. What about the potential energy of a system of n point charges? So let us do that. A very important one, that if it is asked for 1 mark question, the potential energy of a system of n point charges, then it will be given by what? The potential energy of system of n point charges will be how much? U is equals to k into, there will be a summation sign I equal to 1 to n and summation sign j is equal to 1 to n, and it will be qi qj divided by rij, provided your I cannot be equal to j. Okay, so this will be your answer. But remember, here you are seeing q1 q3, are you seeing q3 q1 term? So it is not there. So but if I make only this much, then this term is also included. So I have to neglect this q3 q1, I have to choose any one, either q1 q3 or q3 q1. So what I have to do, I have to multiply by 1 by 2. If I divide by 2, then I will take only one thing into consideration. So I hope it is clear for 1 mark and 3 mark how to answer it. Moving to the next one. Here what we will do is, we will find out the potential energy of a system of point charges. Here we will find out the potential energy of a system of 2 point charges, in an external field. Okay, in the presence of an external field, that means the source charge is already present. So let us see how it is different from the other one. What happens here is, you already have a source charge q, and in the presence of source charge q, what you do is, you bring two charges and keep it. Okay, suppose this is the position p1 and this is the position p2. Okay, in the presence of charge q2, you bring q1 from infinity, and keep it at position 1. Okay, you will find out what is the amount of work done. Then you bring q2 from infinity, and keep it at p2. While doing so, what will be the work done? So what is the total work done? Total work done because of this charge, work done for this charge. You have to add both of them. Okay, so now let us find out for this situation. And moreover, the distance between the two charges, here it is r12. So I hope it is clear that how this derivation will be different from the previous one. In the previous one, we don't have any source charge, we bring 3 charges, but here already there is a source charge before we bring q1 and q2. Okay, so in this case, what we will do, how to proceed? Here we will assume that v(r1) vector, it is your electric potential, it is the electric potential at p1 in presence of the electric field. Who produces the electric field? The source charges produces the electric field. Okay, then what is v(r2) vector? This is the electric potential at p2 in presence of your electric field. Okay, now let us find out the work done. W1 is what? It is the work done to bring charge q1 from infinity to p1. So what will be the work done? W1 will be how much? q1 into the potential is v(r1) vector. Then what? W2. What is W2 will be? W2 is work done to bring charge q2 from infinity to p2. Okay, so W2 will be how much? It will be Q2 VR2 vector. Apart from that, this W2, while bringing Q2, there will be another work done. Why? Because of the charge Q1 which is present before you bring the charge Q2. Okay, for that, the work done on Q2 against against the force exerted by Q1. What will be its value? It will be K Q1 Q2 divided by R12. Okay, so finally what we can write? Finally the total potential energy will be Q1 VR1 plus Q2 VR2 plus K Q1 Q2 divided by R12. So this will be the final expression. Okay, so this is how you can find out the potential energy of a system of 2-point charges in the presence of an external field or in the presence of a source charge. Okay, so today's last concept what we are going to study, you already know it, a very simple one, that is your electron volt. Okay, this is very easy to understand, we also know it from our previous classes what it is. So electron volt is the potential energy gained or lost. It is gained or lost by an electron in moving through a potential difference of 1 volt. Okay, so basically your delta U will be Q into delta V. If we try to calculate its value, electron is the charge, so charge will be 1.6 into 10 to the power minus 19 coulomb. Okay, into, and what is the potential difference between the two plates? 1 volt, so 1 V, and the unit will be expressed in terms of joule. So it will be 1.6 into 10 to the power minus 19 joule. So therefore we can always use 1 electron volt is equals to 1.6 into 10 to the power minus 19 joule. Okay, so I end my class here with the hope that you like this video. If you like it, do subscribe my channel and share my video so that it will motivate me to give further more videos in the upcoming classes. Any queries you have, you can mail me in the mail ID which is given below. Thank you for your kind patience.